So trying to some magic. Yes, the screen's working. Let's have some applause for Nilesh. Woo!
Thank you. Hi, good morning. Can you hear me at the back? I'm going to talk about API management in AI era. Quick thing about myself. My name is Nilesh Gule. I'm an ex-Microsoft MVP. I was an MVP from 2018 till 2025. And I'm also a Docker captain. I work for Avanade, which is one of the biggest Microsoft partner for last 25 years. And it's a joint venture between Accenture and Microsoft, in case you're not aware about who Avanade is. I'm a big fan of cricket as well. So if somebody wants to talk about cricket after the session or after the event, happy to talk about that. But before we go into the API management, if you are here this morning, you would have heard Mehdi talk about differences between normal API gateways and Gen AI gateways. Let's try to understand some of the things which are required for Gen AI gateway. So when you start talking about generative AI, you would have heard many people ask, or when they start the first step, like hello world, people would give example or ask a question to a large language model saying, why is the sky blue? So I try to use a slightly different version of that. And I asked a question about Melbourne weather, because we are in Melbourne and we have such a high unpredictable weather. I asked a very simple question, like, how is the weather in Melbourne in the month of November? This one was for the Mistral 7 billion instruct model, and it came up with the answer saying it's typically a spring weather, and it gives the temperature range, rainfall, and all that. Now, when I asked this question, if I look at the stats, you will see on the right hand side the three things at the bottom. There is the prompt tokens, which is like 17 tokens for use for that question itself. And then there is the predicted tokens, which is like it predicted to give the response, it would utilize around 93 tokens, but in actual, it took 110 tokens. Now, there are thousands of models available as part of Hugging Face, and every cloud provider or whoever is hosting the models, you will see a lot of variants of model. If I go to a slightly powerful model, like a DeepSeek one, which has the reasoning capability, and I ask the same question, how is the weather in November? It starts to think, it starts to reason. And if you look at the line right at the bottom there where it says DeepSeek R1, and just below that, it thought for almost 4.5 minutes. It reasoned various things, and then it came up with this list of 6 things, and it tried to explain me what is the weather look like in the month of November in Melbourne. And if again you look at the stats, now it's 10 times higher. The number of tokens consumed here or used is more than 1,000 tokens. So what we see here is this tokens is a sort of currency which is used when we are dealing with large language models. And that's one of the reasons why we can't use the same approach that we used to have with traditional API management when it comes to the generative AI or Gen AI based APIs. So that's where I'm going to focus my talk about. And since I'm more familiar with Microsoft suite of technologies, I'm going to reference the Gen AI capabilities of API management. But whatever I discuss here, similar capabilities, they exist in other vendors and products. So we all want to build intelligent apps, right? So that's where we have the intelligent app sections on the left-hand side. And we have the Azure API management, which has additional capability in terms of what they call as the AI gateway. So this allows us to interact with AI services, not just the large language models, which could be the OpenAI models hosted on Microsoft Azure, or it could be other models like Mistral. There are also native Azure services, which are all exposed via this AI gateway. So when we start dealing with Gen AI APIs, there are some challenges now. There are various ones. Because this session is like constrained to 20 minutes, I'll try to focus on 3 of them. First one is, let's assume that we have the model hosted somewhere and we want to start interacting from our application point of view with that model. how do we track the usage across multiple applications? Now, usually we don't have one model per application. We'll be in a shared environment where there is one model hosted and multiple applications are consuming that particular model. So we want to be able to track which application, which API, for example, is consuming how many tokens. The next thing is, because these are hosted models and there are certain quotas and limitations with those models, there is things like the tokens per minute quota. We want to make sure that if there are multiple applications consuming these models, the most critical applications are the ones which are getting the right amount of tokens, and not so critical applications are consuming all the tokens, and when it comes to the actual critical application, they don't have enough bandwidth to consume the models. The third thing is about the disaster recovery kind of scenario, where there are limits in terms of the regions as well, not just at the model level. At the data center level, how many tokens are available, or at the subscription level. So if we have a critical application and we reach the limit at the subscription or at the data center level, how we can fail over to a separate region. So let's look at the first one. How do we monitor the utilization of models? Within the AI gateway or the API management, what we are trying to do here is all the requests that pass through the API gateway, we define a policy which writes the matrix to our monitoring environment. In case of Microsoft Azure, it is the Azure Monitor. So this allows us to understand at different dimensions who is consuming how many tokens. And the way I do that is in our API configuration, we define this policy. So if you look at the last 4 or 5 lines, there is this emit token matrix policy. And we define different dimensions. So I can measure things at the subscription level, at the client IP level, at the API ID, and even at the user level. So when I have this, then I can use this information in my visualization. And in this case, I've got 3 different subscribers subscribing to the same large language model. And we can see like for subscription 3, within this time frame that I'm visualizing, there are like 1.17 thousand tokens consumed, 1.15 for the subscription 1, and similarly 1.1 for subscription 2. So this gives us a view of which consumer is using how much of the tokens. Once we have this view, the next thing is to enforce the limit. This is the situation where we have a shared environment and we want to limit which application or which consumer can consume how many tokens. So it's like a rate limiting, but not at the request level, at the token level. So the way we do that is there is again a token limit policy. And again, if you look at the last 4 lines, there is this token per minute. We can define different time frame. In this case, I am taking token per minute and setting that limit as 500 tokens per minute. This can be extended to like tokens per hour, per week, per month, depending on our needs. And what this allows us to do is, when the consumer starts consuming, so I've sent multiple requests, and you can see that request 1 took around 84 tokens, request 2 is around 82, and because we have set 500 tokens per minute, the moment it reaches, I think, around 8th request, it's crossed 500 tokens. So after that, we get the status code as 429, which means the subsequent request, this particular consumer, it cannot consume more tokens than that. So this way, we are enforcing the limits at the consumer level. Now, the next thing is about the limits at the model level or at the deployment level. And in this example, we can see there are 3 different models mentioned: the GPT 3.5 turbo model, GPT-4, and GPT-4o. Now, all these models, they have a token and a quota limit at the deployment. Now, assume that I'm using multiple of these models for my use cases, and I don't want a situation where I exhaust the limit at the model deployment and I want to utilize something at a higher level. So I can use this concept called provision throughput unit. This allows me to reserve the token's capacity at the subscription level and at the region level, which is like at the data center level. So by using this is similar to using the reserve instances for virtual machines, for example, where we say, okay, I'm going to reserve this much of capacity for next 3 years. So similar to this, the provision throughput unit allows us to have a sort of predictable performance by combining the quota of individual models into a higher level at the subscription and at the region level. And in this scenario, what I want to do is, let's say my application is very critical and I want to make sure that even if I exhaust the provision throughput unit at a particular region, I want to use a fallback mechanism. So instead of relying on just one region, I want to load balance this across multiple regions. So I want to have a provision throughput for my primary region. So the initial set of requests would all go to the primary, and when I'm exhausting that, I want to have this circuit breaker and load balancer which will use the fallback and retry mechanism and redirect the traffic to my secondary. So in this case, I have this configuration where as part of my load balancing, instead of having just one model, I'm having 3 different models. One is hosted in UK South, the other one is in Sweden Central, and third one is in France Central region. The primary one, which has priority 1 and weightage as 100%, is set to the UK South. And when I hit that capacity, the other 2 are set as priority 2. And I can also switch between whether I want to do like a round robin or priority based switching for the other 2, the secondary ones. So in my policy definition, I again set this retry policy, and then based on the status code, I can say if the status code is 429 and if I'm reaching the backend pool limit, now you have to trigger the retry mechanism and switch over to the fallback mechanism. So when I do this configuration and when I run a set of requests, we can see the pink lines. These are the primary inputs, or these are the requests which were served by my primary. And then when that token limit was hit or the threshold was hit, it starts to switch between the 2 secondaries. So I'm sorry, there is light yellow there, which is not very clearly visible, but you can get an idea about that. So these 3 capabilities are what I discussed about, but when it comes to the AI gateway as such, there are a lot of other features which are supported and which are available. It comes under different categories as well. So if you were here yesterday, you would have seen during the keynote that we just can't focus on one area. There is security, there is observability, there is scalability, and we need to address those holistically in all the different areas. So these are the different capabilities and how they map to different categories. And here are some of the things that I discussed in terms of the token limits and the policies. These are demonstrated in a live video. So if you want to see that in action, I did one session for the Microsoft user group in Singapore. Asif, who is the organizer of that group, is also here, and he'll be the next presenter. You can scan that QR code and you can see this live in action. So the slides are published online, and these are the resources that you can refer to. There is also a very good series of videos by this gentleman called Hussein Dalai, who does a lot of things around API management. So if you're interested, he's a good resource to follow in terms of YouTube subscribers. That's me again. Thank you. Thanks for attending. If you have any questions, I'm happy to take maybe 1 or 2 questions.
Can the token limit beyond per request level? Like I want these many tokens at max per request. Can this be said?
you can define that as part of your policy. Yeah.
And is the user experiencing something different when it switches to the secondary load balance? I mean, when it is load balanced to secondary.
Okay, so the question is there a difference in user experience when you switch to the secondary? There is no difference in the user experience, because when you configure it in the API management, from the user point of view, you only see one instance. It is the backend pool which is configured in such a way that there are 3 instances of your model running. So the user is even not aware that there are 3 instances running. And in case you want to try these things on your own, there is also the GenAI Labs, which is published by Microsoft. You can have a look at that. The slides are available on SlideShare and Speaker Deck, and it's very easy with my first name and last name. I never had any problem getting this in most of the social media platforms. So if you combine my first and last name, you will find all these resources. So, thank you. Thanks for coming.
You